Hello everyone, we want to talk about efficiency of a machine. And efficiency of a machine, we want to talk about under it, we talk about definition of machine, the formula and its application. Now efficiency is defined as the ratio of work output to the what? Work input. Now don't forget that this definition can be, we'll talk about work output. What is work output? Work output is simply what? Load times distance moved or distance of load. What about work input? From that definition, we will say what? Work input is equals to what? Effort times distance of efforts. Now, if you agree that now, we can now say efficiency is equal to work output over work input. Now, in converting it, because efficiency must be in percentage, so anytime we are working with it, we must ensure our answer is in percentage. So we multiply by 100%. But if you are giving efficiency, there is no need to put 100% here again. Let's say we are giving work output, work input. It will be in form of ratio. Then to convert it to percentage, in terms of decimal, you multiply by 100. Now, another thing again you must note is that we have what they call two types of machine. We have what they call the ideal machine, and we have the practical machine. Now, in ideal machine, what we assume is that in ideal machine, the machine is 100%. In an ideal machine, the machine has an efficiency of 100%. But in a practical machine, the machine has less than 100% efficiency. So 100% what? Efficiency. This one less than 100% what? Efficiency. Another thing again you must note is that for us to have efficiency of 100%, it means that in this ID machine, the work output is balanced by the work, it's got to work input. But in this case, the work input is greater than what? Work output. So where is the remaining value? Where did they go to? They are the remaining work is used as what? Is used by friction to produce it. So that is why the machine here will get hot. There is no machine that can work at 100%. We call this one a perfect machine. So a perfect machine is a machine that operates at 100% that doesn't lose energy. That's what we call a perfect machine or an ideal machine. So now, this one now, the working part, the rubbing part, the moving part are produce it, and that it makes the work input to be not to be greater than work out. So that is work input is equal to work output plus work done by it or friction. So that is the efficiency of the machine. Now another thing again is that in this case now, velocity ratio is equal to mechanical advantage. We are going to talk about that. How does it lead to velocity ratio equal to mechanical advantage. We have talked about the definition. I've given you formula which we are analyzing now is a formula. Then what about the unit first? The unit of efficiency mathematically is percentage, but in physics no unit. We know that efficiency is 100% is percentage in mathematics, but in physics it has no unit. But most of the times when you solve efficiency, you leave the answer in percentage. Percentage is a mathematical unit but not a physics unit. So we convert it to what? That's why this one does not have a dimension. If not, if it's a physics unit, it's supposed to have a dimension, but it does not have a dimension. That means that it's a mathematical unit. Though we see leave our answer in percentage when we solve for efficiency. Take note of that. So the unit now, so we can say efficiency is measured. Let me put it that way. Efficiency in a better way is measured in percentage. Because I put unit here, some people might mix it up. Now, the next thing is that in a machine, why is a machine not 100%? Look at the board. Let me say efficiency equal to, let's substitute this formula there, these two formula. We are going to have what? Load times distance moved by load, and load times distance moved by load. Then effort times distance moved by effort. So in that case, we are going to put it here. Effort times distance moved by effort is load times distance moved by load. Now let us multiply by 100 or leave that one first. Do you know we can write this one as load over effort times 1 divided by distance moved by effort over distance moved by load. We can write it like this mathematically, because this one will still, this one is like this, we pick it out, then this one take the inverse, let this one be coming under, which is if you go up, you will still be the same thing. So what is now this formula load by effort is mechanical advantage times what is the inverse of 1 GE over DL, distance by load over distance by effort, distance by effort over distance by load is the same thing as what? Distance by load over distance by effort. So we will have 1 over velocity ratio. So that means efficiency is also the same as mechanical advantage over velocity ratio. So that is another formula times 100%. So please take note of this again. I'm giving one here. So important formula. Now the next thing is that, which is the last one, don't forget your load over effort is mechanical advantage. So somebody else can say that load divided by effort divided by velocity ratio times 100% is also what? Equal to efficiency. So we can also use this one to solve problem and so forth and so on. So there are several things we need to know about this, which we are going to be applying on that question. Somebody else can even replace the work input and place it here. You can solve from here. You can say work input is minus work done by friction by heat is equal to work output. So in place of the what work output, I can place this one here. There are some questions that will require that to place it here. I believe I'll be able to explain this particular efficiency to an extent. Ensure that you know that no machine can operate at what? At 100%. And don't forget, if the machine operates at 100%, it means that the velocity ratio equal to mechanical advantage. And in this case, velocity ratio is greater than what? Mechanical advantage. Please take note of that. But in this case, velocity ratio is equal to mechanical advantage. And don't forget, the machine can be reduced by what? Efficiency of the machine can be reduced by friction. The higher the friction, the lesser the what? The efficiency of the machine, and the lesser the work done. So a machine is what? Is used to measure the amount of work done produced in an industry. So if I want to know how far a machine has worked, what is the efficiency of the machine, the working process of the working measurement of that machine tells us how efficient that machine is. Maybe a machine produce 500 bags of so and it's supposed to produce 1,000, means that the working efficiency is less, is reduced. So that is what efficiency can do for you. It measures the amount of work done produced in a factory or in an industry. Thank you very much. God bless you.